Yes, so let's move on towards our next topic of discussion. So we will start with scalar matrix. Okay. I had already told you regarding diagonal matrix in the previous lecture. In this lecture, I am going to tell you about scalar matrix. Okay. So what is a scalar matrix? Let's have a look. So let me tell you first of all. Then we will have a look at the definition. But for the time being, just have a look at this particular slide. Okay. And what does it mean? So actually, it is like this. Okay, you already know that these big zeros can be written like this. Okay, these huge big zeros can be written in this manner. Okay, so this is the meaning of this particular 3 cross 3 matrix. Okay, now 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 compare this with this particular a11, a12, a13. Okay, this is the general representation of a 3 cross 3 matrix. A21, a22, a23, then a31, a32, and a3. So what does it mean actually? So the meaning is that this is the first row. Okay, so this is first row, first column a11, first row, second column a12, first row, third column a13, second row, first column a21, second row, second column a22, second row, third column a23, third row, first column a31, third row, second column a32, third row, third column a33. Okay, so this is the meaning. Now try to fit the definition with this particular thing. Now a square matrix A equal to Aij is called scalar matrix. Is called scalar matrix if I double if means if and only if. Okay, so Aij equal to k if I equal to j, but k is not equal to 1. So you can have a look. For I equal to j, what are the elements corresponding to I equal to j? Corresponding to I equal to j, corresponding to this I equal to j, there are three elements a11, a22, a33, a11, a22, a33, which are the diagonal elements. Okay, so this implies that they are diagonal elements, and that diagonal element is equal to k, but k is not equal to 1. So it can be anything. For example, we can have 2, 2, 2. Okay, all of them must be equal but not equal to 1. So 2, 2, and 2. Okay, but 2 is not equal to 1, so that it satisfies the condition. And other places where I is not equal to j, so non-diagonal elements are there. This element, this element, this element, this element, this element, and this element. These three elements above and three elements below the diagonal, these are non-diagonal elements. Okay, 1, 2, 3, 4, 5, 6, these are non-diagonal elements, and I is not equal to j for non-diagonal elements. So I is not equal to j, 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 and I is not equal to j. So those elements must be 0. So 0, 0, 0, 0, 0, 0. So you can have a look 0, 0, 0, 0, 0, 0. So this is clearly a scalar matrix. This is clearly a scalar matrix. Okay. So another example of scalar matrix. What is another example of scalar matrix? Another example will be something like this: 888, 0, 0, 0, 0, 0, 0. This is another example of scalar matrix. Okay, this is another example of scalar matrix, but this is not a scalar matrix. Which one? This one. 1, 1, 1, 0, 0, 0, 0, 0, 0. This is not a scalar matrix. This is not a scalar matrix. Why? Why is this not a scalar matrix? Because it is clearly stated that k should not be equal to 1. K should not be equal to 1. And here, over here in this particular matrix, k is equal to 1. But k should not be equal to 1. Okay. So this is not a scalar matrix. Okay. This is not a scalar matrix. But this one, okay, these two are examples of scalar matrix. Now let us have a look at the definition of scalar matrix. What does the definition want to say? Let us have a look. A diagonal matrix A equal to Aij. Okay. So clearly this is also a diagonal matrix, and this is also a diagonal matrix. Okay, what is diagonal matrix? I have already told you in the previous lecture, so no need to tell once again what is diagonal matrix. Okay, so a diagonal matrix A equal to Aij is called scalar matrix if all the non-diagonal elements are equal to 0. Okay, all the non-diagonal elements are equal to 0, and all diagonal elements are equal, all diagonal elements are equal, all diagonal elements are equal, okay, all diagonal elements are equal over here also, and all diagonal elements are equal over here also, okay. So all diagonal elements equal, all diagonal elements are equal but not equal to unity, okay, but not equal to unity. So this particular case is not covered, okay. So this is the meaning of scalar matrix. Have a look once again. A diagonal matrix, okay, so a matrix of this kind, but these three elements will be equal, okay, and not equal to 1. That is the thing. It will be a diagonal matrix, but it will be called a scalar matrix if this element, and this element are equal. All the three diagonal elements are equal, but not equal to 1. But not equal to 1. Unity means 1, so not equal to unity or not equal to 1. But other elements are 0. So 2, 2, 2, 0, 0, 0, 0, 0, 0 is a scalar matrix. Okay. Then 45, 45, 45, 0, 0, 0, 0, 0, 0. This is also a scalar matrix. Okay. But as soon as I substitute this particular place, with 1, okay, over here it is 0. If I substitute it with 1, what will happen? This will not be a scalar matrix. Why? Because these diagonal elements must be equal but not equal to unity. Not equal to unity is a condition, okay. So this is scalar matrix, but this is not a scalar matrix, okay. Similarly, we can have numerous other examples, okay. So this is the meaning of scalar matrix. I have also taught you the mathematical definition. I have also taught you the mathematical definition, as well as I have also taught you the this definition, okay. Along with mathematical definition in words also I have told you, okay. So both type of definitions I have told you. Thank you very much.